Hello, my name is Michal. If you put 2.53 times 10 to the power of 24 molecules of an unknown compound on a balance, you will discover that the mass is 757.8 grams. What is the identity of the unknown compound? Hint: find the molar mass and then calculate the molar masses of the following compounds. The definition of molar mass is grams of a compound per mole. As you can see in our question, our unit is in molecules. We need to convert molecules to moles. We need to use Avogadro's number to solve that. There are 2.53 times 10 to the power of 24 molecules of a compound, and from Avogadro's number definition, there are 7.02 times 10 to the power of 23 molecules in 1 mole of any compound. After setting up the equation and solving for the number of moles, you should get an answer of 4.2 moles. We now have a mass and number of moles of a compound. If 4.2 moles of a compound have a mass of 757.8 grams, then what is the mass of 1 mole? It is exactly the same procedure as in the last example. Let's set up a proportion and solve for number of grams. Did you get 180.5 grams? That's correct. So the molar mass is 180.5 grams per mole. Now which of the following answer is correct? In order to determine that, we need molar mass of each compound. I didn't include my work for this part, but you should be able to solve it. You should be able to tell that one of the answers is very close to what we calculated. C6H12O6 is the correct answer to that problem. Let's take a deep breath because next problem is harder than the previous two. When 135 grams of a non-covalent compound is dissolved in 450 grams of water, the freezing point of the solution is negative 3.21 degrees Celsius. Find the molar mass of the covalent compound. Follow these steps. Step A. What is the molarity of solution? Use delta TFP equals MT times KFP and solve for MT. Note that since this is a covalent compound, MT equals the molarity of the solute because covalent compounds do not dissociate. Okay, well, one constant is necessary to solve this part, KFP of water. KFP of water is 1.853 degrees Celsius per molality. Using the formula delta TFP equals MT times KFP, we can solve it for MT. So mt equals delta TFP divided by KFP. Now, using our formula sheet, we know that freezing point solution equals freezing point solvent minus delta TF. Freezing point of the solvent is 0 Celsius, and based on the equation, freezing point of a solution is negative 3.21 Celsius. We are now able to solve for delta TF. It is equal to 3.21 degrees Celsius. Now we have all values necessary to solve for mt. It is just 3.21 degrees Celsius over 1.835 Celsius over molality, which equals 1.73 m. Part B says, how many moles of solid were dissolved? Multiply your answer to part A by the kilograms of solvent. Molality is moles of solute over kilogram of solvent. Our calculated molality is 1.73 m, which means that 1.73 moles of compound dissolve in 1 kilogram of water, but we do not have exactly 1 kilogram of water. The problem tells us that there is 450 grams of water. So if 1.73 moles dissolve in 1 kilogram of water, then how much will dissolve in 0.43 kilogram? By setting up the equation, we get number of moles to be 0.779 moles. Part C says, calculate the molar mass of the compound. Take the mass of the solute given in the problem and divide by your answer to part B. This part should not be a problem. We are given the mass and we calculate the number of moles. So we are able to calculate molar mass. Divide the mass by number of moles and you should get 173 grams per mole. We are done with question 3. Let's go to question 4. Find the molar mass of a covalent compound if 210 grams of the substance is dissolved in 810 grams of water, changes the boiling point of the solution to 101.3 degrees Celsius. Okay, well, we need kBp in order to do anything with this problem. It is 0.515 degrees Celsius per molality. We know that boiling point total is boiling point solvent plus delta TB. From this equation we can figure out delta T. Delta T is equal to 1.3 degrees Celsius. We have to find molality of the solution. From equation delta TBP equals mt times kBp, we are able to calculate mt, because we are given the values of two other variables. After rearranging the equation, we should get a value of 2.52 molality. For every 1 kilogram of water, 2.52 moles of the compound dissolve. So how many moles dissolve in amount water we are given in the problem? We need to multiply our molality by the mass of water, and we should have 2.04 moles for the answer. Now that we solved for number of moles of the compound, we are able to find molar mass, because you are given the mass of the compound in the problem. So divide the mass by number of moles. I hope you got 103 grams per mole for your answer. Let's go to question 5. Find the molar mass of a covalent compound if 38.5 grams dissolves in 520 grams of water to give a freezing point of negative 2.15 degrees Celsius. We know that freezing point of a solution is freezing point solvent minus delta TF. We know the freezing point of solution and freezing point of the solvent, so we are able to solve for delta T. After substituting those values to the equation, we get delta T to be equal to 2.15 degrees Celsius. Now using the formula delta TFP equals mt times KFP, we are able to solve for mt, which in this case will equal to 1.16 molality. So if 1.16 moles of a compound dissolves in 1 kilogram of water, then how many moles of compound will dissolve in 0.52 kilogram of water? It's a sample ratio problem. We can divide 1.16 mol m by 0.52 kilograms and we will get an answer of 0.603 moles. Now that we have number of moles, we can find the molar mass of a compound, because we also know its mass. 38.5 grams over 0.603 moles equals to 63.8 grams per mole. Let's go to question 6. When 282.5 grams of a covalent compound is dissolved in 630 grams of water, the vapor pressure lowers from 3.2 kilopascal to 2.1 kilopascal. What is the molar mass of the compound? Use the following steps. Part A says, use Raoult's law to find the mole fraction of the water. Solve for X solvent. From the equation P solvent equals X solvent times P naught solvent, we are able to solve for X solvent because we are given the final and initial pressures of solution. 2.1 kilopascal divided by 3.2 kilopascal is equal to 0.656. Part B is very easy. Convert grams of water to moles of water. 630 grams of water over 80 grams of water per 1 mole is equal to 34.96 moles. Part C. Use the mole fraction equation below and your answer to part B to solve for mole solute. Let mole solute be X. Now substitute all the values we know to the equation and solve for X. 0.656 equals 34.96 moles divided by parentheses 34.96 moles plus X close parentheses. After rearranging the equation, we will get an answer of X equals 18.33 moles. Part D simply tells you what operation to do. Divide the mass of the compound given in the equation, given the question, by your answer to part C to find the molar mass. 282.5 grams divided by 18.33 moles will give us 15 grams per mole for an answer. Question 7 is very similar to the previous question. Find the molar mass of covalent solute if when 371 grams of the solute are added to 650 grams of water, the vapor pressure changes from 4.2 kilopascal to 2.8 kilopascal. Let's find the mole fraction first. From the equation P solvent equals X solvent times P naught solvent, we are able to solve for X solvent, which in this case equal to 0.67. Now let's find the number of moles of the solvent. There are 650 grams of water and there are 18.02 grams of water in 1 mole. So we have 36.07 moles of water. Now we can plug in our values to the equation. Let moles of solute be X and let's solve for X. 0.67 equals 36.07 moles divided by parentheses 36.07 moles plus X close parentheses. After doing some work, we will eventually get an answer of 18.04 moles. The final part of this problem is simple. Let's divide our number of grams by number of moles so we can get a molar mass of a compound, which is equal to 20.6 grams per mole. We are down to the last question of ChemQuest. Question 8. 230 grams of a covalent solute are dissolved in 520 grams of water. The vapor pressure changes from 3.5 kilopascal to 2.9 kilopascal. What is the freezing point of the solution? Hint: first find the moles of solute using Raoult's law, and then find molality use delta TFP equals NT times KFP. We will perform exact steps as in the last examples. So P solvent equals X solvent times P naught solvent. Let's plug in our given values for pressure and solve for X solvent. X solvent equals to 0.83. Now we need number of mole of the solvent. So let's divide our mass of water by its molar mass. The number of moles of water equals 28.86 moles. Now we can plug those values into the equation. Let's call moles of solute X and then let's solve for X. Our starting line should be 0.83 equals 28.86 moles divided by parenthesis 28.86 moles plus X close parenthesis. After rearranging the equation, we will get an answer of X equals 5.91 moles. In order to find the freezing point of the solution, we need a molality. Molality is moles of solute divided by kilogram of solvent. So, if 5.91 moles dissolves in 0.52 kg of water, then how much will dissolve in 1 kilogram? 5.91 moles divided by 0.52 kilograms of water gives us 11.37 m. We know that delta TFP equals mt times KFP, and we know the value of KFP, so it is just 11.37 molality times 1.853 degrees Celsius divided by molality, which equals to 21.1 degrees Celsius. The last part is to figure out the freezing point of the solution. We just calculated the delta T and we know the freezing point of the pure water. Freezing point solution is freezing point of solvent minus delta TF. So it's just 0 minus 21.1 degrees Celsius, which equals to negative 21.1 degrees Celsius. We are done with ChemQuest problems, but we still have 5 more to go, because we still have 5 more problems for skill practice. Question 1. When 230 grams of an unknown covalent compound is dissolved in 410 kilograms of water, then the freezing point of the solution is negative 3.51 degrees Celsius. Find the molar mass of the compound. Now at this point you should be able to see from the problem that we will need molality and moles of water, so solve for those. Freezing point of solution is freezing point of solvent minus delta TF. We are able to solve for delta T, which should equal to 3.51 degrees Celsius. We are able now to solve for MT. Delta TFP equals MT times KFP. MT will be 3.51 degrees Celsius over 1.853 degrees Celsius over m, which equals to 1.89 m. Molality equals moles of solute over kilogram of solvent. 1.83 moles of solute will dissolve in 1 kilogram of water. So how much will dissolve in 0.41 kilogram of water? It's a ratio problem, so let's set up an equation. This will give us an answer of 0.775 moles. Now we can divide the mass of a compound by the moles of a compound. So our molar mass is 297 grams per mole. Now let me tell you something about the next problem. I spent 2 days trying to solve it, but eventually I couldn't. You will see why as I will go through the steps. Find the molar mass of a covalent compound if 125 grams dissolved in water changes the vapor pressure from 3.4 kilopascal to 1.8 kilopascal. We are given initial and final pressures of the solution, so we should use Raoult's law. P solvent equals X solvent times P not solvent. By solving the equation we get an answer of X solvent equals 0.529. Now we need to solve the equation and find moles of solute. We have no information about how much water is there, so let's call moles of solvent X and moles of solute Y. Our equation should look like that. 0.529 equals X over parentheses X plus Y close parentheses. We are able to simplify this equation a little bit, so our final line is Y equals 0.89X. Now what does it tell us? It gives us the relation of moles of solute and moles of solvent, but can we actually solve it? No. There is one equation and two variables, so we cannot do anything with it. The answer on the line, though, is 5.05 grams per mole. So let's find out, just for practice, how much water was there initially by doing the problem backwards. Moles of solute is Y, which is 125 grams over parentheses 5.05 grams per mole close parentheses. That equals to 24.75 moles. So 24.75 moles equals 0.89x. Divide both sides by 0.89 and x equals to 27.8 moles. So there was 27 moles of water. 27.8 moles of water. After we convert it to grams, we get 501 grams of water, which approximately we can say 0.5 kilograms of water. Question 3. When 180 grams of an unknown covalent compound is dissolved in 430 grams of water, the boiling point changes to 101.52 degrees Celsius. What is the molar mass of the compound? So, boiling point total is boiling point solvent plus delta Tb. So we can solve for delta T by substituting the values that we know. Our delta T is therefore 1.52 degrees Celsius. We didn't need molality, so we can solve for it using delta Tb equals mt times kBp. 1.52 degrees Celsius over 0.515 degrees Celsius over m equals 2.95 m. So, if 2.95 moles of solute dissolve in 1 kilogram of water, then how much will dissolve in 0.43 kilograms of water? Isn't that the ratio problem that we can easily do? Set up the equation and our answer is 1.27 moles. Now it's the easiest part. Divide number of grams of a compound by the moles number of moles. The molar mass is equal to 142 grams per mole. Question 4. The boiling point of a 1.25 molality solution is 101.2 degrees Celsius. Find the molar mass of the covalent solute if the mass percent of solute in the solution is 15.2%. Something new here, mass percent. Mass percent of solute basically means the ratio of mass of solute to the mass of total solution. Let's assume there is 1000 grams of solvent. You will see why in a moment. We need moles of solute. We are given its molality. By assuming there is 1000 grams of water, the number of moles of solute is basically the numerical value of the molality, because the definition of molality is moles of solute divided by 1 kilogram solvent. We need the mass of solute since it's mass percent problem. Let's call molar mass of the solute Y. We know that molar mass times the number of moles gives the mass. So 1.25y divided by parentheses 1.25y plus 1000 grams close parentheses equals 0.152. We are able to simplify the equation and solve for y. It takes a while to do it, but eventually our y is equal to 143 grams per mole. One more question. Find the molar mass of a covalent compound that when dissolved in water to make a 2.1 m solution, the freezing point becomes negative 2.53 degrees Celsius. The mass percent of solute is 17.5%. Mass percent problem again. So let's start this problem similar way as in the last problem. Let's assume there is 1000 grams of water. So the number of moles of the solute is 2.1 moles. Molar mass times number of moles gives us the mass, so let's call molar mass Y. Therefore our equation is 2.1y over parentheses 2.1y plus 1000 grams close parentheses equal to 0.175. We can simplify that, and at the end we will get an answer of 101 grams per mole. We probably wonder what we had to do with the freezing point given in the problem. Nothing, it's just a distractor. Let's move on to question 6. Oh, there is no question 6. We are done. I hope you became better with the concept of using colligative properties. These problems were not easy, so if you felt okay doing this, and you understood the work I did for each problem, then you are in a good shape for the AP Chemistry class. Thank you for your attention and good luck.